Section 6.6, Function Operations. By the end of today's lesson, students are going to be able to add, subtract, multiply, and divide two functions, as well as find the composite of two functions. Let's first look at the function operations. If you are given f plus g of x, that means take the function f of x and add it to g of x by combining like terms. When doing subtraction and you have f minus g of x, that means take your function f of x and subtract g of x. Now before you just go and subtract, make sure you distribute your negative sign and then combine like terms. When multiplying f times g of x, to multiply, you take the function of x and you multiply it by the function of g. So that means you'll either have to distribute or possibly FOIL, depending on what was given to you. When you're dividing f by g of x, you take the function of x, or f, put it on the top, and you divide it by the function of g. When talking about function operation, we are also going to have to consider the domains of both of the functions that are given and use the most restricted domain. Let's first look at adding and subtracting functions. So before you can even add or subtract, they have to give you the two functions that you're using. So in this case, we're using f of x is 2x squared minus 3x plus 8, and g of x is x minus 3. So when it's asking you to add, it's either going to write find f plus g, or it could ask find f plus g of x, or it could write f of x plus g of x. All of these things mean the same thing, and it just means take your function of f and add it to g. So my f of x is 2x squared minus 3x plus 8, and then we are going to add it to x minus 3. And when you're adding, all what you do is you combine like terms. So there's no other x squared, so you have 2x squared, and then you combine like terms, you have negative 3x plus x, and that gives you negative 2x. And then you have 8 minus 3, which gives you 5. Now we have to talk about their domain. So you have to look at multiple things. So let's first look at the domain of f of x, okay? So f of x is 2x squared minus 3x plus 8. You know that x squared is a parabola, so the domain is negative infinity to positive infinity. All right, now let's look at the domain, but this time of g of x. So g of x is x minus 3. X minus 3 is a line, and the domain for lines are negative infinity to positive infinity. And the last thing we have to look at is the domain of your answer. And your answer, remember, is 2x squared minus 2x plus 5. Again, since it's x squared, it's a parabola, so the domain is negative infinity to positive infinity. So normally you would compare all three of these, and you would look for the most restricted one, but since they're all the same thing, the domain overall is also negative infinity to positive infinity. So these are your two answers right here. In example 2, we are going to start by subtracting f minus g. So you take f of x, which is the square root of x plus 2x minus 5, and we are going to subtract 4x minus 5. Okay, something for you to remember. I didn't just make these up. You are going to be given these two functions. And if you forget to distribute your minus sign, you're not going to get the same answer. So that leaves me with the square root of x plus 2x minus 5 minus 4x plus 5. All right, combine like terms. So I have my square root of x. There's nothing for me to combine there. 2x minus 4x gives me negative 2x. And then negative 5 plus 5 gives me 0. Now let's talk about the domain of f of x, okay? So since you are given this square root, there are certain numbers that you can't plug into x since it's a square root. So you can plug in all positive numbers, and you can plug in 0, but you can't plug in negative numbers. So the domain is, 0 to infinity. The domain for g of x is much simpler. 4x minus 5 is a line, so the domain is negative infinity to positive infinity. All right, now let's look at the domain of your answer. All right, the domain of your answer, again, you have this square root that's here, so I can't plug in any negative numbers, so its domain is still 0 to infinity. So now we look at all three of these domains, and you're picking the one that's the most restricted. So the one that's the most restricted is these two. They're the exact same thing. So the domain for your overall is 0 to infinity. So this is your answer for subtracting them, and this is the domain for that as well. Now we're going to look at multiplying and dividing functions. So the two functions that are given to you are 3x squared minus 11x minus 4, and then gx plus 1. And all we're going to do is we're going to take f of x and multiply it by g of x. So I'm going to take 3x squared minus 11x minus 4, and I'm going to multiply it by 3x plus 1. Okay, so that means we need to FOIL this. So we take 3x squared and we multiply it by 3x, and that gives me 9x cubed. Then we take 3x squared and we multiply it by positive 1, and we get 3x squared. Then we take minus 11x and we multiply it by 3x, and we get negative 33x squared. Negative 11x times 1 gives me negative 11x. Last one, take negative 4 and we multiply it by 3x, and we get negative 12x. And then we take negative 4 and we multiply it by 1, and we get negative 4. Now we have to combine like terms, so we have 9x cubed, and then 3x squared minus 33x squared gives me negative 30x squared. Negative 11x minus 12x is going to give me minus 23x, and then we have minus 4. Let's talk about the domain of f of x. So the domain, all right, so I gave you 3x squared minus 11x minus 4. Since it's squared, that means it's a parabola, and the domain for a parabola is negative infinity to positive infinity. Okay, now let's talk about the domain for g of x. G of x, they gave us 3x plus 1. This is a line, so the domain for lines is also negative infinity to positive infinity. Now let's look at the domain of your answer. And since you're given 9x cubed minus 30x squared minus 23x minus 4. This is just a polynomial, and the domains of polynomials are also negative infinity to positive infinity. So my domain overall is, since all three of these are the exact same thing, the most restricted one is the exact same thing, negative infinity to positive infinity. So your two answers, when you multiply it together, is this and that. Now let's look at dividing two functions, and I'm going to use the exact same functions from example 3. So what I do is I take f, which is 3x squared minus 11x minus 4, and I put it on top of 3x plus 1. Okay, so in this problem you need to try to factor what has been given to you. So to factor 3x squared minus 11x minus 4, you ask yourself what multiplies to negative 12, that adds to negative 11. So negative 12 times positive 1 gives me negative 12. Negative 12 plus 1 gives me negative 11. So I bring down my first term, then I write minus 12x, then I write positive 1x, and I bring down my minus 4. Split it in half. What goes into 3x squared and negative 12x? 3x, and that leaves you with x minus 4. Bring down the plus sign. Only 1 goes into x minus 4, so you're left with x minus 4. So this factors to x minus 4 times 3x plus 1. Okay, so I go ahead and I write that in the top now because this factors to x minus 4 and 3x plus 1. And then I still divide it by 3x plus 1. Now, since there's the exact same thing in the top and the bottom, this cancels out, and I'm left with x minus 4 as my answer. Now, on the last side, we said that the domain of f of x was negative infinity to positive infinity. The domain of g of x, same thing, negative infinity to positive infinity. Now, the domain of my answer, this is where it gets different. When you are given this is what we started with. I cannot have 0 in my denominator because it would make my function undefined. So I take my denominator, which is 3x plus 1, and it cannot equal 0 because it would make it undefined. Subtract 1, divide by 3, so x cannot equal negative 1/3. So for my domain, for my answer, it would be negative infinity to negative 1/3 union negative 1/3 to infinity. So which one of these three is the most restricted? This one is the most restricted. So the domain overall is negative infinity to negative 1/3 union negative 1/3 to infinity. So your answer is x minus 4, and the domain for that is this. Composite functions is where you are going to put basically a function inside of another function. So you see this written like this, g of f of x, okay? This open dot does not mean multiplication, it means of. Or you can see it written like this, g of f of x. Okay, so that means you first plug your function in for f, and then you plug that answer into g. Now we're going to look at an example doing composition functions. So again, you have to be given two functions, and then it has to tell you the order you're going to go in and what you're going to plug in. So this says f of g of 2. So I like writing it as f of g of 2 because now I can see I do my inner parentheses first, and then I'm going to take that answer and I'm going to plug it in second. So we're going to start with the first part, g of 2. So I have 2 in for x, 2 squared equals 4. So now I'm going to do f of 4. So I have 2 times 4 plus 1. 2 times 4 is 8. Plus 1 is 9. So your answer is just the number 9. In our example number 6, this time we are given g of f of x, and we're not given a number to plug in. So again, I would rewrite this as g of f of x. So we start by plugging in f of x in for g. So since this is already f of x, all that I do is I take 2x squared minus 6 and I write it right here. So I'm left with g of 2x squared minus 6. So that means in g, wherever there is an x, you are going to replace it with 2x squared minus 6. So I have 4 parentheses 2x squared minus 6 minus 3. And obviously we need to simplify that. So we are going to start by distributing 4 times 2x squared, which gives me 8x squared. And then 4 times negative 6 gives me minus 24. And then we have minus 3. So our final answer for this problem is going to be 8x squared minus 27.